First of all, thanks to the organizers for organizing this wonderful meeting year after year. So what started a little bit as a hobby and tinkering with data over time became a bit of a serious research, especially with my students Ritampal and Anjaney Kumar joining in and taking it forward. So the results of most of what I'm going to say is there in this paper, and there's also further results in this archive version, which I'll not be talking about. Okay, the first question to answer would be not so much why study election. I'm sure everyone kind of appreciates it, but why physicists should study elections. Firstly, it's largest examples of collective decision making by humans anywhere, which is very well recorded in terms of data sets. And also, you would recognize that this is a process where microscopic interactions of all kinds at all scales finally leads to macroscopic outcomes. So you could think of it as a statistical physics problem. And it has all the telltale signs of a complex system. So you could take anything like whole is not equal to sum of the parts, or it is indeed unpredictable, and complex interactions are there among all kinds of agents, and so on. And it so happened that the last year, 2024, was a super year for elections because there were 64 national elections across the world involving 2 billion people. So now, before I go ahead to say something about model data, let me actually state what an election is for our purposes. So election is something that is held over n electoral units. So if you have Indian elections in mind, so you have large number of constituencies. Each of them is an electoral unit. And in general, it could be a constituency, county, precinct, or even a polling booth. And in each of those constituencies, you have CI number of candidates who contest the election, and there are NI number of voters. And of those NI number of voters, only TI who actually come out to vote. So this is one important quantity that you'll have to keep in mind. And a voter can make only one choice of the candidate. So there are many different voting systems. So the one that we stick to is what is called the first past the post system. The one who takes the most votes wins. And the margin is defined by the difference between the winner's vote and the runner-up vote. So the two quantities which is going to be of important for us is one, the turnout, and the other is the margin. So you can already see that margin and turnout are kind of related in the sense that margin can only be bounded between 0 and the turnout. And if you divide this entire inequality by TI, it will tell you that the ratio margin by turnout has to lie between 0 and 1. Okay, so now let's take some motivation from real data. So for example, this is Raichur Lok Sabha constituency in 2014. The margin of victory was only 1,499 votes, and the total turnout was about 16.6 lakhs. Now, in some other polling booth, the margin was exactly the same, 1,499, but the turnout was, because it's a polling booth, the number of people who vote there in a polling booth is of the order of 1,000. So the turnout is only 1,600. So now, this one is a closely fought election because out of 16.6 lakh votes, the margin is wafer thin, just 1,500 or so. So you would say that the winner just scraped through. On the other hand, here it's a landslide because of total possible 1,600 votes, almost 1,500 votes went to one candidate. So here is a case of same margin, but completely two different scenarios. So this is what gives us the first lesson that margin actually makes sense only in the context of turnout. So margin alone does not tell the full story. So since the time is short, let me actually put out the final result, which is like the take-home message, and then maybe explain rest of the stuff. So what we had shown in this work is that, so now if you go and examine the data from 34 countries, so this represents data of elections collected over almost more than 100 years for 34 countries. And you look at this quantity, which is margin divided by turnout divided by the average of margin by turnout. So that's a metric of interest. Okay. So the distribution of this X actually falls, there's a very good data collapse, and you see a kind of universality. So there are several curves here. So one is these colored dots, they correspond to the data, actual empirical election data. And then, for example, this red line is the analytical data which comes from the, is the analytical expression which comes from the model. And then there is aggregated data as well. So the central result is that the distribution of scaled specific margin, basically this quantity X, is universal, irrespective of where and when the elections are held. Okay. So this is important simply because people have been trying to find universality in election data for almost last 50 years. Various attempts have been made, but nothing that could be said as a universal behavior across all elections, across all countries, all levels, and so on. No such behavior was ever found. And so again, to go back to where we get the data from, so Election Commission of India maintains a wonderful website right from 1951 when the first elections in free India were held. You have all the detailed data of all of that. And then there are also these other sites which will tell you, which will give you very detailed data. So this one I just wanted to project from one of the election reports, just to say that it's enough to look at just the top 3 candidates, or sometimes even top 2 candidates, simply because they actually carry almost more than 90% of all the votes ever polled. So even though you don't need to really model with 20 and 30 candidates in every election. Finally, this is our random voting model. It's a very simple model. The input is number of electoral units, which is number of constituencies to fix your ideas. And NC is the number of candidates and number of voters. And the model is very simple. First, you define how attractive a candidate is to a voter, which defines this probability, where this Wij is simply drawn from a uniform distribution between 0 and 1. And each voter makes only one choice, which is dictated by this Pij. And you just run this process and run an election synthetically in your computer, and you can compute this margin. So the question is this model any good? Turns out that the first lesson was that turnout and margin are somehow related, but you can actually make a stronger claim. If you give me the raw turnout data, this is the raw turnout, basically the turnout that's given in all the election reports, take that for various countries and put it through this random voting model here, and it will give you the margin, and compare that margin distribution with the actual margin distribution that comes out of the election data. So you get an exact beautiful agreement here. And so the lesson is that you can make a claim that turnout distribution drives the margin distribution. You can actually prove that analytically as well for certain classes of turnout distributions. And it works at all the scales, meaning that you can look at it at polling booth level, at constituency level, at say assembly constituency level, at Lok Sabha constituency level. These represent different scales of elections. And again, all this works perfectly well. And finally, this is the central result. So this is the data drawn from 34 countries. And on top of it, this is the aggregated data. And finally, the RVM simulations, the random voting model, you do the simulations and it agrees very well. And finally, you can actually solve the random voting model and obtain an analytical expression, which also agrees very well. Okay, I think I'll, due to lack of time, let me stop here. This is for, you can look at it for each and every country. It's there in the supplementary material, and you can actually use this to detect large-scale electoral malpractices. So whenever you see deviations from this universality behavior, it's probably due to some such malpractice. So I think I'll stop here. Thank you very much. For more details, you're welcome to see this website.
Data from various years also, right?
Yeah, that's right. Yeah.
But probably things will depend upon first 50 years of democracy versus...
Yeah, but for the quantity that we are looking, which is the margin, it does not matter. So elections themselves are changing all over the world. So like for instance, even in India, there was once paper ballot, now we have EVM and so on. But if you're looking at this particular quantity, which is the margin, I don't think that matters. See, we have actually done that like segmented in, like for instance, for US, the data dates back to 1780s and so on. So we've checked it across different, like collecting together several decades and so on. It falls in the right universality curve.
All right, so looking at the deviations, so with what confidence you can say that there was a malpractice or it was a fair election?
I didn't have time to say that. So this is the expected universality. And the data put out by these two countries, when we actually do our analysis, actually does not fall on that. So it shows this blue curve. So we expect that in these cases, maybe there's something wrong with the election. I mean, you can complain how sitting in Pune, you can declare some election in some country to be fraud. But that's why we look at the news reports from, these are old elections, and there are enough news reports that say that these are known to be fixed elections. So this is in some sense what is already known in the newspaper, in media. We are able to kind of see it in the data as well.
But if somebody is clever and they read your paper, they can still rig the election and fit the data as it.
Okay, good question. I think it's much harder to fix because you need to fix the margins across all your constituencies at every polling booth level. I would expect it's hard, but we don't know.
All right, sir. So just one question. Across some scales, were you happen to see any cases of gerrymandering, which is like manipulation of electoral boundaries to some rules?
Yeah, see, every case of malpractice, unless it is a really large-scale malpractice, whether it is gerrymandering and other things, it will not show up in this data.
Okay,
so it has to be sufficiently big enough that it should show up as a deviation. So let's say you do it in one or two places, it wouldn't actually show up. Yeah. At least for India, we've done quite a bit of analysis. We don't see any such thing in that.
Okay. And some sort of opinion, sentiment analysis with clustering techniques that influence
Okay,
the
so yeah, there are, I mean, these are things in the pipeline. We have not done those things.
Thank you.
Further questions can be discussed after the session. Let's thank the speaker on our behalf.